Good morning, or whatever it is, wherever you are. So we cut that right between a song. So I've been having the curse of interesting times. Seems like about everything happened yesterday. Well, Monday night I hit a gravel patch on my bike and fell. Mostly fine. I haven't been able to really walk on my left leg. I think that's getting better. There's definitely nothing broken. I'll give that at least another day before worrying too much about it. I also had the new fiber internet guy coming yesterday, but it will be a little while until I can actually get it into this room. The things that kind of made sense for the house didn't really make sense for getting it here right now. So I'm just going to get a really long cable at first, and then especially when I'm feeling better, I'm going to see about putting like a pass-through jack in one of the walls so I can cut that down a bit. Something a little bit nicer at least. So anyway, the problem is we're trying to do a formatted number control. And sort of as a little practice exercise, we are doing this thing as its own little component. This means that the subcontrol and the parent form, which has to be able to put all this stuff together to be able to do these calculations, are like fighting over the state. Yeah, so actually in particular, right now you cannot properly really do anything with this. Because it's like sending an update and then the parent is resetting the prop, which this is bitrate. We want bit per pixel control. Yeah, which we're trying to do this stuff, then you get those weird effects like being able to go back through a 0 and then suddenly have it replaced. So what I did for this with Elm was I had to keep a current string output around in the top level model so that you would never replace what the user had typed. You would always interpret that, except when you were manually setting the value. But if we're pushing that back up to the parent component, it's going to push that converted value back down to us, and we're not going to be able to tell that state value as being in any way distinct from an actual we calculated something. Now, there is going to be one other thing here that we might be able to work with, in that the eventual purpose of this is to pick an optimization target. So like right now, I only have code to calculate bitrate out of all this stuff, or bits per pixel. The idea being that when you're in this mode, this will be a read-only control. And then we can switch over to this, and then this would become the read-only control. So these controls could use that read-only property to sort of change how they're handling the input, which is to say, if it's read-only, then we have our string state. And if it's read-only, we just take the prop and stick it in there. If it is not read-only, then we do string value to value and we ignore props pretty much and ship our value back to the parent. And probably when the point where you're changing that state is where it's going to be interesting. Because you'd have to have that moment where you say, well, okay, we were receiving the value. Well, no, I guess when it's doing that, it would convert it to string and display that still. So then when you switch to not read-only, it would just switch the update direction. And I think I actually slept last night, but it did kind of remember a bunch of stuff starting out. Or right before bed. And just kind of moving slow at everything, because every once in a while you hit that spot that hurts, or that position that hurts. All right, so solving this actually kind of means solving the read-only problem. So we converted it to text, right, because number didn't like doing like a 0 dot, for instance. Which I think is one of the reasons I did millibits per pixel on the OBS one. I think we're going to have to do this. Whip, keeping string value for BPP. So we actually have to go back up to bitrate calculator. And we have to deal with I wonder if it'll complain about having read-only and unchange on this. Because having to conditionally assign the properties sounds ugly. So we have a target. So we really care about this for this purpose. Read only equals this dot target equals BPP. Read only, yes, that is correct. This dot target is equal to that. And the control is actually implementing that. So state, yeah, we don't have any representation. Well, did it get pushed over? Ah. Okay, BPP control, read only false. No, bitrate calculator. Did I not call it bit per pixel? It's not radio bit per pixel. Target bits per pixel. Wait. What the heck am I even doing? Checked as target, so that... Oh, that's... Because I was looking at the function call above it. Yeah, I can't even click in it. Okay. So we would rather implement that at the control level. Changed string value. This is almost going to be like a functionally different thing. So this is going to be more like... So we don't need pre-value, I don't think. And then the value gets sent up. So I'm not sure you actually need it. So if props.readOnly, then string value is props.value. If props is not read-only, well, we're still updating our string value. So changed string value just shouldn't happen if we're in read-only mode. I guess we'd look at the console for complaining about read-only change conflicts. So this sort of accomplishes the two-state thing. Hey, how about we save? Okay, so I can type whatever in there. Now I might possibly want to do some filtering to like just remove like non-numerical characters. I think I was having trouble with typing this when it was a numeric type field. If we switch back, that suggests yeah. I might actually want to associate these labels with the I might need to associate the labels with the radio button so I can get the click-through on that. So while we're read-only, we're resetting string value to the value. While we are not read-only, we're constantly sending down value here. So this seems to suggest that we are not sending this up. Okay. value equals, value equals. Oh, because once we put this back, because everything we do, or many things we do to update the parent control are going to cause a bitrate recalculation, which means we have to finish implementing this. With all of our additional calculations. Oh, and you know what? If I'm going to do this, bitrate calculator should really be doing this for all of these controls. Because that will become a programmatically controlled field. Oh, none of these implement that though. So BPP, and it's pretty much just pass through. So bitrate control on the input. Frame rate control on the input. And resolution control on the input. And we currently didn't hit save here. Does read-only not work on selects? We know it worked for one of you. Read-only true. Well, you're a select. Oh, I was putting in the slider. The slider should probably be read-only as well. And resolution control. Okay, can't select that. Okay. Okay, well, at least that one did something. Sliders don't seem to accept read-only. Input range disabled. Actually, you know what? Disabled might actually be better than read-only. Gets sent when the according form submits. A disabled form isn't editable and isn't sent on submit. Can be focused. Disabled elements cannot. Not past the processor method. Default styling. Do not receive focus. Do not have read-only attributes, although we'll have to disabled attributes. All right, so sounds like we want to, well, I mean, it should really be read-only or disabled, I guess, on the other one. All right, so bitrate control. Frame rate control. BPP control. Which means others don't implement read-only at all. If props dot disabled bitrate calculator actually read-only disabled. Well, we didn't get any visual styling there. Oh, wait, dynamic attribute. Right, because it's not disabled equals value. JSX spread attributes. Well, that's what I was trying to do. Disables the button. To conditionally set. Well, that was in 2017. Transferring propped. Oh, it has to be undefined, not true false. Oh, or did we not save? I'd say we hadn't saved. Okay, so that's a little bit better feedback. And this will still update through there. Okay. Now we've got to do all the stuff, but we were just seeing some things about spread attributes there. So let's see. instance them anyway. Once bit per pixel is a control, well, I think bit per pixel can get higher if you're going recording level, but for streaming, oh, I actually want to put streaming bitrate calculator on here. Anyway. What's new in ES6? New features and overview and comparison. That's probably about the level we want. Support for constants. So those might be some things we can use. So we start in app. Okay, we picked some up from our sample code. Calculate BPP is a function. Does that make sense as a const? I guess so. We're not going to replace the function. Target equals, well, within the space of this function call, yeah. So we have all the compiled files. Bitrate is a parse int. Const for as much as we use it. Change string value, frame rate options, frame rate. Resolution options, when we find, I think that stays constant. No more items, no complaints from the compiler. With the help of object properties, if not in block scope. Writable, configurable, yeah. Block scoped variables. Okay. Wait, so our const's block scoped. Oop, that was a reload. ES6 const scope. Kind of makes sense. The battle between function scope. If all of the new stuff was scoped. Okay, I understand how var. Okay, so and const introduces block scope. I am trying to learn the features of the newer version of JavaScript and also a bunch of other technologies, the particular framework called React. For that, as an exercise, I'm building a web version of the bitrate calculator I did for OBS. Which, given that I couldn't really actually do a whole lot of integration with OBS, it might actually be a better form for it. When function scoping, the differences. Local variable inside a scope with the same name. var name, const func. Covers functions and not other types of blocks. Ah. Okay. Block scoped. Not really talking about const. Lazy functions into an array. Yeah, so that's the old traditional problem where it gets bound, or the variable is put in there. So that's I to I. All right, that was putting the extra function binding in there. Ah, it's let in the for can use that. Okay, so it was introduced as a const, or let and const being block scoped. So yeah, I kind of tended to lazily use that style, even though I just had to kind of watch out for the situations. Block scoped functions. Right, so we kind of used immediately invoked functions to get similar effects before. So shorthand for functions. Actually, let's cd into source for this. We're not getting up junk. Okay, we have an implicit return value with these. Although it looks like we may have to bracket curly braces. So this is all statement bodies. And then if you need to go longer, you can put the brackets in there, which is why the other thing needed the parentheses around it. I mean, this is small-ish, but I don't know that we necessarily need. So like this kind of thing would be where you've got this, and you've got our implicit return value. So this is the options for resolution. No, this is the options for frame rate. Okay, that still seems to be fine. This would be the kind of little thing where the shorthand would make more sense. Find function, return, map, return, no more items. So that fits you. We still have options. Okay. Ah, that's our interesting. They're showing. Is that a language difference, or is that a style, or is that them trying to make ES6 look cleaner? This, self, yeah, okay. Extended parameter handling. Oh. Straight up default values. I don't think I did that anywhere. Nothing was jumping out as doing a lot of parameter checking. Bitrate control. Yeah, and most of them are pretty similar. Okay, so default values there if we need them. We already kind of touched on this because it solved some problems. Aggregation of remaining arguments into single parameter veridic functions. Okay, so we can insert into an array, which we also kind of touched on. And into a function call. So there was some note about like using that to like pass down disabled for most of these. You would essentially have how would you determine the rest of the non-standard props? Like we're putting class name up there. So that would be I might have seen, yeah, there's some destructuring down there. So you could hand pick certain props and then just splat them in there, maybe a little less verbosely. String interpolation. I might have done some string concatenation. Okay, it's trying to meta-interpret that. I'm not really sure that it's going to be that big of a win here because we're just sticking some things together. Custom interpolation. Okay, so you can put expressions in there. Cool. That's just pointing out that it can be an expression. Raw template string contents. Backslashes are not interpreted. String.raw. Foo42 bar. Foo, so you get break it, new lines. Oh, no, at the template, strings, foobar, strings.raw, foobar, without backslash. Value 0. So are values assumed to alternate with strings then? And I guess that would make sense. Huh. Oh wait, shouldn't there... Doesn't... What is resolution control? Maybe I already used the template format here. Oh, yep, I did. Template strings are always... Okay, so template strings are backslashes. And then you can attach a template string to a function. Oh, and it's array of strings and then all of the arguments. Okay, nice. Unicode and string, literal. Sticky matching. Matching position sticky between matches. I guess this is more important if you get into that stuff. You'd probably have to run this code for it to make any sense at all. I don't think that directly affects me. Property shorthand. Oh. That's not going to be an easy thing to search for. I could, So like conceivably here you could do it. And, well, this has a different name. We could totally do that, and then that becomes a stick in. Bitrate control. Resolution control. Frame rate control is going to be pretty similar. EPP control. String value. Computed property names in object definitions. Method properties. Method notation in object property definitions. Oh, that's the top level function notation. Okay, I don't think I did any of that yet. Array matching. Okay. Okay, shorthand notation. That would be one way to handle disabled. Destructure that out of props. Well, you could make it a slightly shorter statement. That's no, because that destructures to a value. The individual variables. Says what to assign it to. Okay, last one. Okay, so you can destructure with a default value. You can do it during function calls. Well, I mean, the constructor functions need all the props. You could conceivably pop like props or state into individual values like in your render, and then use those instead of the this thoughts. Fail soft destructuring. So it just doesn't get defined if it's not there. Export function. Export. Still using var, huh? Export sum, export pi. Import math. Import as math from libmath. We have math.sum, sum pi to use them directly. I could conceivably look at getting the React libraries to work with the ES6 thing that we've got that running. So the main awkward thing is the main awkward reason with that is that this gives us a single place to specify development. If we're saying import React, is it development or is it production? Well, I imagine that React, because they were actually suggesting a little bit more of that style. Hello world. And this is actually kind of sticking back to the level I started at. This is still very library. Maybe it wasn't this. And there's create React app. And Yeah. Thinking in React. Without ES6, yeah, they're not talking about imports at all. Yeah, so I might just have to leave that for now. Default exported value. Export star from libmath. Okay. Export var e, export default. So you get the default thing, and you can also get other attributes if you want to. It might make sense with components. Okay, so that's similar to object. You don't have the commas between them. We already saw this in the React examples. We've got inheritance with super, which we see in React components themselves. Extending from expressions yielding functioning objects. Generic aggregation function is usually provided by a library. What, so global var aggregation? Oh, extends aggregation. So aggregation is a function. So base class mixins. So we have a class expression. Copies of the properties. Well, yeah, because they were always just objects, so a function that returns an object makes sense. Class is just a syntactic sugar. Although you do get supers. I'm not sure exactly how that goes in. Constructor toString, constructor super, super toString. Static, which is going to be essentially on the constructor function. Or not just with an object as is possible since 5.1. Yeah, I think it was, well, was it 5.0 or 5.1 that added all the other object method? Guess that's a standard. Corrects some errors. Contains no new language or library. So that must have just been a update of the 5.0 feature that was not well implemented or widely implemented. And then you can use that you can use it like a property. That type of stuff is nice in Ruby. I don't know. We'll have to see if it makes sense anywhere. Unique and immutable data type identifier for object properties. Yeah, so you do that. Get own property symbols. So they're just suggesting. Yeah, maybe if there's a dot in it, then it changes the behavior. Oh, you can construct these. If there's a dot in it, you can construct an instance anywhere, and it's the same symbol. But, well, it won't be a string per se on the object. So you are less likely to have collisions on object keys. But anybody who does need it can just go in with the symbol for and construct the property. Iterable protocol. Okay, so iterator must be a global symbol. So Fibonacci has this special global symbol for iterator. And it's a function which returns a next, or an object with next. So we've let scoped pre-incur to here. We use the array syntax to update both of them on each loop. And I'm assuming done and value are part of the protocol, and you can use it with for loops. Okay. Yeah, Fibonacci not next if break. Generator functions. Special case of iterators getting a generator function can be paused and resumed. Okay, so if we do a star must be generator. This is also an iterator. Don't know if it has to. Oh, iterator protocol, direct use. So if it's a star, it's a generator, and you can yield from it. And it's still usable, and it's an iterator, it's still usable there. If it's not a property, it's a postfix star. Well, no. Depending on how you consider spacing. I don't know if it's a function star or you could do star range. And then it ends with yield. Of range. Generator functions. What is matching? Oh, so you can splat it in and get the rest. That's fancy. Asynchronous programming. Async function provided by a library. Async generator. So this is yield used not as the return value of a generator, I think. Maybe it's statement versus value form? Is this? It's matching. Generator methods, okay. And that's where you get the star prefix. Okay, I didn't scroll down far enough. So is the yield just to say we're calling an async function? And not, because this is saying async of a generator. Console log result. Generic async control flow driver. Proc of params, proc params. Async is just a promise. It's not a generator itself. The function it calls is supposed to return a iterator of some sort. Which seems to be a promise in this case. Result.done, resolve. Promise says resolve reject. Iterator.next value is the return of the proc. Async is just, yeah, it's just making it async by making it a promise. That's some gnarly stuff that I probably won't need too often. But I need to be able to recognize stars and yields for the most part. So we have a set structure to clean that up. Yep, that's, well, I mean, I guess it's to be more formal about what you're doing than just using the objects. Right, because that would not have any possible confusion with properties and object keys. And, yeah, and you can iterate more cleanly. And then you have weak map and weak set, which I assume have similar APIs. Byte-based data structures. So I know of typed arrays as their own thing. Not specifically as ES6. That's a bit more special purpose. Built-in methods. Dest source 1, source 2, object at assign, dest source 1, source 2. Yeah, I thought that this stuff came out around ES5-ish. Oh, find the element. Wait. No, there's index of... I think. Unless I get my languages crossed up. So resolution definitely used a list. Oh, I just automatically used fine. You know what? I probably went and looked up the ES6 array methods. Oh, and apparently you don't need to parenthesize. Yeah. That's what I would assume. Which covers most of these? And that was an actual index. But there's apparently... Oh no, index of is a value. Find index lets you use a... Well... Did index of only do values? Value, yep. Okay. Probably their function changes show up here. That would be a simple one. Oop. Hadn't saved yet. Yes. Okay. Well, unless it's trying to meta character that must have been the only one. So we just did resolution. Okay, so that was about it for that. String repeating. Well, this is, I went looking for like ES6, differences, essentially. And this seemed to be obvious thing. Now, the test app is a streaming bitrate calculator that I'm kind of slowly building up. Just from as close to plain Jane JavaScript as I could get. I did do some ES6 just to make the examples easier. Then I introduced JSX, extracted some components, and right now I'm kind of doing a check-in on other ES6 features that have been added before I look at actually implementing multi-way calculations. Right now they only do bit per pixel calculations. Okay, so that's cute. Starts with, ends with, includes. Okay, a little bit more. I mean, documentary isn't quite the right word. Explicit, maybe? clearer, transparent. Oh, really? Isnan was not a thing before. Isnan is finite. Exactly. So right now I'm streaming on a bitrate that OBS will test as 12 something in its self-test mode. And the recommended bits per pixel, well, this is where calculating the other directions makes sense. I actually implemented this already as a OBS little plugin thing. So it's the same idea. But I found a spreadsheet that basically says you want about 0.1 for streaming, and when I was having these issues, I was actually running around 2000, or when I started having more trouble, I was actually running around 720, 30. So that was like about 7.2-ish, 7.5-ish. And I was reasonably happy with that. If I looked at it more closely, maybe I would see some artifacting that I wouldn't like now. But at around 1200, we've got, like half of the recommended amount. So like right now, I'm doing 10 frames so I can get up around here. And then for gaming and high motion stuff, where you would like to be 30 frames, 480 seems to be about what we can do comfortably. Yeah, in theory, this is about what I was doing at the 2000 bit rate, but it seems like as your resolution increases, those artifacts become less noticeable. But I was like, I've tried bumping it up, and like I see those artifacts where like the screen moves and then it stops, and then everything sharpens up, and that bugs me personally, so I've not wanted to push into that. Even though it might be okay for certain applications. But yeah, one of the things feature-wise I'll work on next is being able to switch this to like bitrate target. And then say, well, if I want to achieve this bits per pixel and this frame rate, what bitrate would I need to use? Or if I want 30 frames, no, that would calculate the frame rate. So like if I wanted to calculate, okay, what resolution could I do with this bitrate and this quality target? So that's where we're going to go next. And most of that's just writing different functions. I don't know of any fancy ways to do that all in one. No, that was checking back with some React stuff. And I'm just kind of going through the ES6 stuff to see what might be helpful. Safe integer. Correctly represented by... Oh, interesting. Standard epsilon value. Number.epsilon. I mean, that all depends on your targets. What resolution? Well, that's actually not super easy to do here. But if we can change this, which had kind of a crummier interface. Yeah. So target resolution. So this was my original 7.5. This would be 100 if you want the recommendations from the other thing. And this is all messed up. So that would be 800. I mean, if you're willing for enough artifacting, maybe. So probably 30. And sometimes for some of these you have to refresh. I'm not sure I believe that. Is it updating? That's out of range, probably. Well, actually, 432 is less than what I'm doing. So recommended there. So like I do. I wonder if this broke. Well, no, that's making it. Oh no, these things are where you have to refresh. That's right. Oh, and we originally hit this at 75. Well, actually, 360 is probably the lowest. So 100 is the original recommendation. If we go like I do that. I'm wondering if this broke somewhere. Oh, nope. Okay. So I guess I'm technically... Oh, because my FPS bumped when I was changing stuff. Okay, that would explain that. So at my settings, 480 at 800. Yeah. So this is saying at this settings your millibits per pixel will be 115, which is better than that. Which actually, oh yeah. So with a little bit of artifacting, you could do 432. And I don't know exactly where. None. FPS 30, 480 is calculated at 65. Whereas I would calculate it 97 at 1200. So yeah, I did a bunch of test videos, which probably wouldn't go well since like I'm running 10 frames per second in order to do the higher resolution for all the small programming text. So my test videos would probably not look very good here, even if I played them. You might, I mean, maybe you can still see it, but then you're like double encoding things, so it gets a little weird. Okay, so there's a number.epsilon. There's kind of integral part. Okay. And there's a math.sign function. First class representation. Okay, so there's promises are standardized, I presume. Promise combination, promise.all. Oh boy, metaprogramming. New proxy. So target is a foo, get receiver. If name is in receiver, receiver name, else hello name. Okay. Object equals A, define property B. Well, define property was there before. Symbol C, reflect own keys. Well, getting an array is nice. And maybe there's some more stuff in reflect. All right, I've never gotten into internationalization stuff. Having formats available is nice, though. All right, so I'm assuming this is kind of put in usefulness order. So consts, block scoping, good everyday stuff. Arrow functions I've already seen all over the place. Haven't seen a lot of the default values. Might be something I would have even noticed. Spreads I've been seeing, and seems it has some applications. String templates, and that's... Yeah, property shorthand, maybe computed properties, method properties. Destructuring is stuff we can potentially use. Did I run across it in this application? Module stuff is one of the things I already had to dip into. Classes, which are kind of part of the React thing. Iterators and generators are getting more advanced. Maps and sets probably have applications. Promises for or first class promises or built-in promises. I don't know how that works. All right, so we've got all of this. So we've got a const, we've got some shorthand, which those might be overdoing it. It was kind of an exercise in using the feature, but arrow functions. I ended up hitting Ruby around when the web came out. I was actually doing the language before that, and it's like, whoa, well, there's this Rails thing people keep talking about. I did some JavaScript stuff. Originally, it was ES6 dashboard widgets, but I was kind of playing with... no, I don't have it linked here. So I've got a whole set of these things. So I was playing around with Canvas when it was just this like thing that was in ES6 dashboard and kind of incidentally in Safari. So I kind of interested in JavaScript there. Lately, I've been playing around with Elm more. I figured if I'm gonna get into compiling a language, I might as well learn something a little bit more different. Although I might come back and try to do some TypeScript on this at some point. I'm not 100% sure if that's in the project I'm on, but I know it's a thing that's out there and shows up a lot and is going to give you some of the same things as Elm does. But I've done C++ and microcontrollers and all the SQL databasey stuff. C++, I've done a little bit of Python. I dabbled in dozens of things at least. I've been doing some Lua for a couple of things, like the OBS calculators in Lua and all those scripts. There's some in Stepmania. So yeah, whatever gets the job done. There's also Python. I guess it felt like a little heavier weight. You have to get your own installation of Python. I don't think it can handle some of the threading stuff as well. And you cannot do custom sources because that deals into some dangerous threading stuff. And in fact, I've had to do essentially breaking up scripts to get them on different script locks to work around some threading issues. So, do I not have that on here? I used to have it full time. Did I actually remove it? Oh, no, there we go. So that's the dropped frame graph, which is a custom thing, which thankfully isn't up too much right now. But sometimes I kind of leave it up there just to keep an eye on congestion and stuff. And then I've got the mic check, which I kind of wanted a state report from it, so I did a custom draw source for that. And those when I did it, a year ago, was not available to Python because it gets kind of a little more intertwined with the OBS internals. All right, water's out. I probably should take a break, and switching back to making this multi-directional is going to be a nice little subject break. So I'm going to take a little break, refill my water, generally get up and move a little bit. Now, I am moving really slow right now, so it might be a little bit longer than usual, but I will be back in a few minutes. Yep. Even more subdued than my... Oh, you can flip the rover at any time now. Neat. I guess in this situation that would be um 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 drop it, drop.
Yeah, it's basically World War I with cannibalism.
Rip. Now he didn't get XP. He did, but not much. Because he didn't kill it. Then let's kill this thing.
Ow! Ow! And fight's almost over. Ow! Ow! Fight's over. Can we get some more damage going here, please? Artillery beam? You're so awesome! Let's do that. Boom, boom, boom. His weapons are basically down at this point. We're really... I feel like I would have liked... There we go. That's a good amount of damage. Yeah, man, artillery beam's on point. 2 missiles, 1 drone, 35 scrap, won't accept surrender. Third time that artillery beam is a total bro and takes out their cloaking. Boom! 1 fuel, 1 drone, 45 scrap. Nice.
I fucking up hit her, what the fuck?
Got her!
Nice.
Welcome back, everybody. I had to remember to unmute myself. Yep.
You'll never take us alive. Unknown research.
Okay, more research.
More research.
Is there more?
More research.
Debris.
A lot of research over here. Good stuffs.
Clay.
Then that should just be consistent. Oh shit, I'm wasting her food. Whoops. See, that's the thing. Because I went by.
Okay. What there is another act. Huh? Well, that was a successful run, I guess.
Okay, install this in the... Okay, I'm just gonna say... Do that. Rescue Mayors. Carry him... No. That's his bed, okay. Rescue Mayors. Carry him to the bed in the mountain, basically. That way.
Alright, welcome back. Oh, I should update title. And we're still going to be kind of keeping an eye out for this stuff, but... I don't know anything that's going to too terribly cover, touch on the React side of things here. Maybe we can find a place to use some new tricks here, but I don't know. So our calculator has a function that calculates bits per pixel given all of the other stuff. And I have been wondering if I know the OBS app was like width and height, or I'm using this subj object here. So I might want to reconsider that sometime. I don't think it's really going to be too big an issue here. So we do have, from our OBS work, the math pretty well laid out for that. Yeah, so there's our optimization targets. Yeah, I was just always calculating bits per pixel, I guess, so that you can just do it. So I actually just had these as locals, because it was kind of how the OBS sample script works. Right. So for picking settings, I had a table, where I kind of like fudged pixels per second to kind of represent the overall video quality, so to speak. And then detail so that's establishing these ranges. Which, do I need these elsewhere? No. Maybe that was for like debug reporting or something. And then detail is the number of pixels divided by the number of frames. Right. Assuming a constant bit rate, more frames means things get blurrier. Because you can afford less bits per each individual frame. So calculate detail, that was actually a one-time setup. So optimize for bit rate is straight up math. Optimize for resolution needs video options. And optimize for Oh, right. So really, I only need FPS for this resolution sorted by detail and resolution for this FPS sorted by detail, but you can basically do that in one table. You just filter down to the options you need. All right, so targeting bitrate is just math. And let's get you over here. So actually, let's step back here. This is actually a place where you have possibly some room to do bitrate, resolution, width, height, frame rate. That might actually be a place that's doing enough stuff in a small space. I'm going to want to be able to see my compiler in case it complains about something. Well, it complained about something all right. It's just not showing up here. State. Oh, right. How about we change the actual code? And that makes the formula easier to see. And then we extend that style to calculate bitrate, which does not need the bitrate because we're calculating it, and does want bits per pixel. And we already have math on that worked out. Now, I think I was doing some stuff differently, possibly. Where's optimize, well, update bits per pixel. Yeah, this app was storing bits per pixel internally. But if I want to do a display thing there, I'm going to have to do like the bits per pixel display where it gets done up in different units. Maybe we'll come back to that later. So return width times height times frame rate. Oh, right. This is just going to be the bits per pixel. I'm going to use that as our target. All right, and then where we would have calculated bits per pixel, yes, going to default to that mode. Changed bitrate. We recalculate that. So now this gets interesting because now we actually have to do our optimization in direction. So these are pretty much straight up math given our intermediate objective stats. Optimize is going to switch off of target which is also a member of state. So yeah, optimize could take the entire state. It could be, right, because these always have to pass a intermediate state that's been partially updated. Change target. Speaking of which, this may have to handle an intermediate target. So either target should be a parameter to the switcher. Or we should pass through the I guess the calculate functions don't need that. So we could do target and the rest of our state. No, in JavaScript it's switch target. You could do an object for this. But you'd still want probably... It'd be better to handle the case where it wasn't in present. And this also does because we have sparse calculations right now. So bitrate, calculate, bitrate. Oh no, it's case. I need a break, I think. Sure, here. And default. And I switched quotes here. Yep. All right, my compiler was unhappy about something. One of the things I don't like about Babel is that it doesn't put out a success line. So you're never completely sure you fixed it just by looking at the compiler output. Okay, so that's there. 1.8 should be fine. All right, you know, called the functions might be helpful. Maybe. Oh, so I... So this isn't going to work. We need the entire object. We only need it here once anyway. So we need the complete state. We want to return the update for just this field. The state's going to be everything. Which means we're going to have to kind of... Oh, right, because we're giving you prev state, which we had to take that, update it, so you can calculate with the right thing. So that has the entire thing. The usual way to do this is to do a sparse update of the fields. And that would avoid trying to update a value that got updated by something else, some sort of parallel event. But this knows what changed. This cares about what the target is. Was there like object data sign? Yes. So what you would return, you know, what you would return instead of doing nothing. Oh, you know what? That means we don't need to weather out the brakes. Because it is returning. It's expecting to be an object assign that. What this would return would be a bit rate. Oop. And a bit per pixel. Oh, you're welcome. And good night. Have a nice sleep. Okay. So then anywhere we do this, we need to return object.assign bitrate optimize on prev state. That's changed bitrate. That is changed resolution. That is changed frame rate. And changed bits per pixel. Right, we actually have a reason to do things like this now. Oh, there's your set state. And then change target. Just have to be careful to do the right thing here. So target, oh, I didn't actually change this one. And prev state needs to be updated with that so that this does the correct calculations. All right, so we calculate bit rate, or bits per pixel, we calculate bits per pixel. The only one we would expect this to, yep, unknown optimization target. So then you're disabled and redonkulous. Oh, right, I forgot about the scale. That's disabled. I should probably be rounding that. Which once again leans me towards I want to display filtering on the bitrate control. Oh, if we're calculating bitrate, I don't. I'm not doing max value. What I should probably do is have the bitrate control have some little error if you go over 6,000. And this will also affect on that. It affects on this, right? Yes. Yeah, frame rate 15 is a little weird. So that would be the required bit rate. If you wanted to achieve those goals. Okay, well, just having the optimization function there helps a lot. But we saw from we did an OBS that it looks like the solution to this is to do this big sort table. So that is... Wait, did I do this all the time. I wander off and forget to commit stuff. Yep. Update to some ES6 syntax. Can calculate recommended bitrate. All right. So our technique for trying to pick the best option within the bitrate limits we've set is to sort of do this thing we call detail sorted list of all of the settings, or all the possible settings, and pre-calculate that up front. Which means our frame rate control is going to have to export this calculator frame rate options. So const calculate detail. So this is a one-off. I don't strictly have to put it in a function, but it's kind of nice to bundle it up and say this is what we're doing here. So we were doing an iteration through resolution options and FPS options. So in JavaScript, we can do, so that was getting both values. I am rusty on my for syntax. So did ES6 have any toys for us here? There's generators. Let n is the value. Actually, did I need indexes for this? Those look like placeholders. I think I could have actually used underscores there. So we could do for res in resolution options for, we've been using frame rate so far here. A detail is res.width times res.height divided by frame rate. Min and max I'm not using. I think that was for debugging purposes. So then we have to have, this is not a, well, if I returned it from here, I could make the return value a const once assigned. But then I would have to have an internal let video options be an object. Well, I think that, oh, no, you're an array. That's an object because that's Lua arrays are objects. And then we are just adding an entry to it. So can you do, well, 'cause I want to rename them. can you rename on a deconstruct? Array matching, object matching, shorthand. Okay, yeah, it's your field, my field. So I could do get AST node from his previous example was OP-LHS. Okay, so original object property W to width. Or especially I should probably keep using WH here, huh? For consistency, and maybe think about changing that later. So width height. Oh, but I was setting width and height in this one. When I use video options, optimize resolution is getting a width and a height. Oh, I was just using height as the value. That's actually not, well, that's fine for all of the resolutions I've currently got. But resolution is the thing we're going to pick. So we can just, well, resolution to stay consistent. Frame rate, and then I had pixels per second. Oh, so I sorted by detail. But then I used pixels per second. Huh. As the best option. Equals res dot width times res dot height times frame rate. Nope, wrong syntax. And then detail. Right, I needed to do this here because I was printing it out and stuff. So then we do const video options equals calculate detail. This could sort of be a generator, but I don't know that there's no parameters. So there's not really a good reason to do that. Assignment to undeclared variable resolution. No, that's still on its previous error. It doesn't calculate detail. Oh. That's right. We have to declare what kind of thing this is. Now, arguably, in each iteration of this, it's probably effectively const. Oh. Frame rate options. res. Oh, I changed it so it could do this. Which, and I'm not sure about that. I'm still unsure about that shorthand syntax. Might be a little bit too much. And hey, how about we return a value? Because the other one was actually doing it. Ooh, I see some nans there. And this is giving me indexes. Right, because all of our width and height values aren't there. Oh, is there a for of? This might have been a... Yeah, okay. Yeah, nothing about that. Yeah, that must have been an existing feature. I've just been out of JavaScript long enough. So we might see that in generators. Yeah. Oh, yep. It's of. Interesting. We've got for in and for of, which isn't checked by this syntax. Or by yeah, maybe I need to update my JavaScript syntax file. All right. So that gives us this. Oh, we haven't sorted it yet. So how does array prototype sort compare function? Okay, so there's a default sort. Unicorn point value is not supplied. Non-undefined array elements are sorted by converting them. Is not supplied. All non-unidentified is a return value of the compare function. In the end, is less than 0. A is lower than B. They are equal. That's not all browsers. We must always return the same value for specific pair of elements. Video options dot. This is an in-place sort, right? Actually, all we care about this is detail, right? Because a detail sort. Now, I don't think they give us a compare. Oh, right, because it's a number. But this is multi-argument. So it's name in the original object. Name in the original object. All right, so we've got 10 at 10 at a very high frame rate. So pixels per second. We are sorting by detail. Oh, we're sorting by best detail first. So our lowest frame rate with our highest resolution. is going to give us lots of... Oh, and it doesn't say anything about how much bitrate it uses. So you kind of go through this to find the first thing where we can handle it. Oh, are any of these... I don't think any of this is going to be affected by the bitrate scaling here. Yeah, so 10, 10, 15. Up near the top, you get your 60s. Well, let's show my pixels per second. Well, detail is height width divided by frame rate, so... Maybe that's an arbitrary number? I'm just thinking what that means. So given a constant bit rate, that would have lower detail. Okay. All right, so then, okay, so we've got that. We've got our video options. To optimize for, well, is optimize FPS? No, it's not really different. Well, to use the order I've been using before. Calculate resolution off of... What does this need? Oh, so right, this is going to get a... We have a bitrate and a target bitrate. So in this one, we're optimizing... Now wait a minute, pixels per second is... Yeah, target pixels per second is like a ratio. But the numbers we're seeing here are very large. Why did I do that? Maybe that definition changed somewhere? So in the OBS version, I had a target that I just kind of kept around. No, target. Oh, right, that's... So it's always just calculating this one based on the settings, which might still be a useful thing to show. Oh, because target is only needed for optimization of these things. Oh, pixels per second. Bit rate divided by... Yeah, bit rate, not bits per pixel. That's where I was getting confused. So given our bit rate we want to hit and our detail we want to hit, we go through all of the frame rates that match our frame rates and try to figure out if we have, which one is the closest on our pixel per second range. And I think what I have to do is I have to multiply bit rate here. Because this one was storing it internally as the higher amount. Which I might still go back to. So we are going to need, out of our state, the bitrate, the frame rate, and the bits per pixel. And this is not going to be a simple return. So let target pixels per second equal bitrate times 1000 divided by bits per pixel. Let best option to follow the current form. So we're going for option of video options. If option dot frames per frame rate equals frame rate, then if we do not have a best option, or I hope we have an abs. Target bits per pixels per second minus option dot pixels per second. So another way to do this, and I don't know that Lua had this. The other way to do this would be options. Is it filter in JavaScript? I jump around to so many different languages. Actually, this array.prototype function methods. Okay, array.prototype. Last index of filter. Yes, it is filter in JavaScript. Given option, which has which also has a frame rate. And then we filter that, and then we, well, sorting requires the two items. Oh yeah, I can't just map to that difference. So we have pixels per second A, and this needs two items. Pixels per second B, and this is B minus A? No. This is math.abs. Target pixels per second minus A B minus math.abs. Target pixels per second minus A. And less than. If this is less than, so that, oops. Right, our parameters. And then you don't like that? Well, we were kind of in the middle of doing this loop. Set the width and height. Yes, something's going to be at the beginning of that array, whether it's relevant or not. Okay, so it doesn't like some syntax here. Equals function. Oh, let equals let. And let equals variable. Frame rate FPS. Do I need to parenthesize when doing this style? Well, it didn't error. Right, when it's just a single argument, probably not a fancy argument. All right, well, I mean, that's just a function. We haven't called the function yet. Resolution, calculate, resolution. So if we set, options is not, video options. And it doesn't seem to be accepting that. Oh, I wonder if, yeah, what are we returning here? And it's still showing its last value. It's the select. Oh, no. Did I not? Oh, right, because this jumped to that screen. So it's still getting value. This is what we defined our target as. State target equals resolution. Yes, that's the disabled. Okay, I think we're done with that. So I need to get into the regular old console. Okay, so my sort is bungled is what this comes down to. So, okay. Console.log AB. Just to be... Wait, where did my... Oh, it's still here. Do I need brackets for a return? It's not calling this function. Did I forget to update something? Did I bungle my checkbox? Radio bitrate, radio resolution. Why are we not calling optimize? Or is it not the, did I mess up the property set? Resolution, calculate resolution. How are we not running? We must have a compiler error. Right, when I did this. I wish I could leave this up and get the reassurance of it actually printing something. So in order to use that, I must have to use bracket form. Okay, here's a bunch of numbers. We're still not actually picking a resolution, though, which is what all this was supposed to be for. All right. That's the one we were originally trying to do. Where's my result? This must be result. And I was trying to get inside of it. So this is the iteration. We don't have target pixels per second here, but it's saying this one's pretty far off. So ret, we're basically going for the smallest difference. I think we might have to do this like list is there. Console.log. Oh. Result is not defined. Oh, no, it was result here. It was a ret-med little function. I probably do need to reassign those labels. Okay, so there are 12 settings for every FPS. So that much worked. And unfortunately, what we don't see here, pixels per second. I might need to print out my target. Four, two, two, 1, 1, 1, 1, 1. Lost a place. Frame rate 60 pixels per second. I'm actually not sure. I think I calculated this from initial settings, which were, I guess, generous. Oh, because it defaults to 360. I don't really set this. But still. Okay, so yeah, now we see, a smaller one and then a huge one. Seems suspicious. Oh, that's detail. Pixels per second. Yeah, they're... Seems like a pretty weird sort to have 360 next to 1080. But to understand this, I actually need more detail. To understand what these are referring to, I'd essentially have to have the inner objects here. I mean, that might actually do it. All right, so we are comparing. They're all going to be 20s. All right, 1080, 900. And our net result is negative. One has a pixels per second of... The lack of commas here can be 41, 28. Bigger screen, that makes sense. So we're getting the absolute difference. And this is saying negative. If compare function is supplied, if it is less than 0, sort A to an index lower than B. A comes first. I guess I need my target here. So I can better evaluate. Well, I mean, really, the net differences are probably what we care about. So it calculates with the current settings. So our target is 6. And we come in here with 1080 and 900. And we get like 62. So, yeah, this feels wrong because 1080 is worse than 30. So maybe we're just stuck on 1080 because it's always the worst option. So it looks like this actually needs to be the other way. Oh, hey, that actually was like the same resolution. And if you change your frame rate, it scales. Although even this is for high bits per pixel. Oh, that might give you some more headroom here. Yeah. So at 30 it's 480. At 10 864. Yeah, I might need to show the actual bits per pixel because you can push things too far. But that's about what we want to see. Trade-offs. Alright, so that was just a certain version. I guess I was going with, I think they had a sample here. Oh, no, it is. Isn't the only one I sorted too. Although maybe Lua's sort is the other way? Table.sort. Well, oh, okay, so we're only caring about up to there. That was a less than. This is a minus. Okay. Oop. Alright, so that is just a little reminder for me. That probably also means, yeah, it's getting later. But with that, well, with this simplified, yeah, it's about as verbose either way. Console log, console log. All right, target bits per second. We don't need this anymore. That was from the looping inversion. In theory, we can go back to return video options. Oop. Uh-oh. Is that a compiler error? That's a compiler error. Did I leave out a parenthesis? Okay. And then calculate frame rate should be just that. Bitrate, frame rate, resolution. So now it's filter for resolution res. And these are objects. They should be comparable. And the sort is still the same. Calculate frame rate. Where are we going wrong? Okay, first of all, we have a compiler error. Oh, calculate resolution. No, calculate, yeah, frame rate. Did it not? Oh, no. Oh, so it didn't like this. I'd swear this one was working, though. Or maybe the version before I did that particular change did? Okay, so you still work. And now we can go the other way. And these will also respond to bitrate scaling. Oh, and now that bits per pixel is a thing, or manipulable control, slider might be nice on that too. That might be, I mean, it'd be an easy change. Next, I had to expose that. Maybe I switched from detail to pixels per second and didn't. And before I was doing a linear scan, we didn't really get early exit on it. That was doing a full examination, so I don't even... Yeah, I think I must have changed from detail to pixels per second. Because other than kind of keeping it in a high bandwidth to low bandwidth thing, I'm not actually sure what detail is doing for me. Now, this is more like... So I've got a bunch of things called calculate, not optimize. Okay, you don't have any complaints? Okay. Commit minus calculate calculate resolution and frame rate. So if we go like bitrate control, changed bitrate. Yeah, it's really just the slider itself. This one would... Oh, Right, this one might want a range. But this, yeah, so the challenge here is that streaming, you're about 0.1. If you get into recording, well, I've already limited my bitrate to 6,000, so you're kind of not doing recording anyway. So for calculating bitrate, then yeah, that it can calculate higher bit rates. All right, I was typing in here. You know, or if you're then doing like, well, I'm recording, so I want 12441. Yeah, the decimal is confusing me. It's the same number of places. Just significantly more. Yeah, so that's like recording rate stuff. But... So actually, since this probably has reasonable bounds... For some reason we have less indent here. Did I, what control bound did I, millibit per pixel? I did 0.05 to 0.5 as a reasonable range. So and step is right, none of these were sliders, so step didn't really matter. 0.01? Uh-oh. Oh, right, we copied stuff. So it's changed bit per pixel, and this should be BPP slider. Changed. Oh, that's expecting a string value, so it's not. All right, so it's a special thing, but this is a number. So to be comparable here, I don't know if there's an actual string. Well, you're target right now, so you can't be dragged. So the unfortunate thing here, you almost want like a logarithmic scale for this one. It's like all your details down around here. So for streaming, you're pretty much in this spot. But yeah, if you're willing to accept the artifacts, you can do a bit with that. Yeah, I don't know if the slider's as useful on this one, because you're not really using a lot of the range. I'd probably need to figure out how to make it logarithmic. I guess for calculating it, and you can kind of see things moving around. Or, I mean, heck, just bit rate. Improving quality. Anyway. Add slider to bitrate scale, not very good. But I don't want to get into... Yeah, figuring out how to do like two scaled things off of the values flying around here might be an interesting little challenge. But that may be a React exercise for later. Technology-wise, we've got Redux and TypeScript as directions we could possibly go next. Well, I'm pretty sure Redux is in use for the project I'm working on, so that would be possibly more topical. I still have to check on whether TypeScript is involved. Anyway, that's it for now. Let's get off of there. Thanks for watching. Thanks for hosting me. I will be back. Well, the plan is to be back in the afternoon to continue our endless run in Frostpunk. And schedule. Oh wait. Oh, I always had that drop frame on here. I'm not sure if I need it. This is about when I tend to be on. Tuesdays and Thursdays are moving out right now, so you'll kind of slowly see them move off. So let's see, I don't know what you're working on. I'm pretty sure that's a game dev thing. You look like you're probably just about over. Well, lots of people are just about over. All right, well, if you're looking for someplace cool to hang out, No Look is working on, I think it's I'm guessing it's a game jam of some sort. So it's like one of the Unities or other environments like that. But if you're looking for someplace cool to hang out, that's someplace cool to hang out. Thanks for goodbye, and until next time.